Hey, happy Sunday. This is PFG Live, the podcast that says, you give us 1 hour, we'll give you the flat. Okay. I don't know how many of you know what that's from. Tucker is checking in. He says it's 55 degrees Fahrenheit and sunny in Buffalo, New York. Josh says audio check, check. And he's in southern Manitoba, where it is 300, 23, gusting 42, temperature 12.05, and remarks that are interesting. Bill Olney from Rome, New York says it's 48 degrees Fahrenheit, 8 miles an hour wind. Sounds lovely. Dale from somewhere in Snow, Texas, he says it's 5 degrees science and mostly sunny. DBX. I don't even want to decode that. Let's see. Who else is here? Let's see. You YouTube guys are slow on the uptake here. We need your weather reports. Here in Windham, New Hampshire, it's apparently 52 degrees and 50% relative humidity with winds out of the west at 8 miles an hour. The Manchester Airport reports winds are 310 at 13, gusting 17, visibility 10 miles, clear, temperature 11, dew point -03, altimeter 3018. And there are incomprehensible remarks. Protean Machining, welcome aboard, sir. He said, get these numbers. He says it's 83 degrees Fahrenheit and 11% relative humidity in sunny Tucson. Now, sunny Tucson is code for my filament dryer, okay? Welcome aboard. Max is with us from somewhere in Southern California. KSNA. KSNA. I'm not sure which one that is. Winds are variable at 5 knots. Visibility 5 miles in haze. Broken at 1,300. Broken at 11,000. Temperature 19. Dew point 14. And there are remarks. Oh, John Wayne. That's John Wayne Airport. Oh, welcome. Great. Excellent. Nice to see you. Let's see. What else? I think we got everybody caught up here. JB Toby says he was lurking on Discord. He is in Harrow, London, rainy and 18 degrees centigrade. Welcome aboard. Casa Frog, Ted says at KLEE, it's 050 at 5 knots, visibility 10 miles, clear, temperature 23, dew point 13, altimeter 3008, and remarks, nice sunny day. It sounds lovely. I actually got a chance to sit outside and contemplate my navel earlier today, and it was really nice. And I look forward to doing some more of that this weekend. The weather here is beautiful. The temperature is a little cool, but otherwise just right. Not like sunny Tucson, where I'm going to send all my filament to dry out. Let's see. We're going to talk a little bit about the filament drying system. Not a lot, because we've been hitting that every week for a while here, and you guys are probably tired of it, but I will give you an update. Oh, look at that. Kurt Langkemper says in Amsterdam, it is 12 degrees science, 53 degrees Frankenstein, rainy, relative humidity 86%, winds are west at 9 knots, and the QNH is 1010 hectopascals. Thank you, sir. Appreciate you being here. Yeah. So it's been a busy week, which is always a good thing. I got new tires this week. So as you know, I drive around a great big battery, and I've been, in fact, you could see it. You could see it right in that picture right there. That thing has been great to me. That's a Ford F-150 Lightning, and I got 32,000 miles on it, and it's been a joy. But the tires started looking like they wanted to get replaced, and with tires, it's like, well, I could run it some more, but should I run it some more, or back and forth? And they were the factory tires, which I'm sure were engineered to be minimum road noise, and that kind of thing. So the wear was a little much, I thought. So I went ahead and I started researching tires. Have you ever researched tires? There were 275 choices for tires for this thing. So finally, I went to the dealer, which I love, Grapponi Ford, up in Bow, New Hampshire. And I said, send me some choices. Yeah, Max says, you don't want old tires in New Hampshire winters. Correctamundo. Anyway, they sent me some choices. I finally ended up picking the Yokohamas, and they look great. So I'm very pleased that that particular project is complete, and I don't have to think about that anymore. But that was on, when was that? Was that Thursday? We got the new tires. And why am I telling you this? In addition to getting the new tires, I had the good fortune of connecting with Warren Jones, who's in the chat right now, who's another member of our Discord and another machinist extraordinaire. And Warren lives north of my dealer. And I said, why don't you come down and meet me? And I had to give him some goods, if you know what I'm saying. I had some stuff wrapped up. I had to pass it to him. So, I don't want to get into that too much. But so Warren came up and we had a very nice visit while I was getting tires. Yeah, Dale says, did you retorque the wheels yet? So, interesting thing. When I brought the, yes, this is a precision machining podcast. We'll get there. When I brought the Subaru into, to get the tires rotated, and inspection and other things, they put it right on the paperwork. We want you to come in, I think it was 5,000 miles, and we're going to retorque your wheels. So that was interesting. And then, not too many days later, I'm up at the Ford dealer. Maybe it was 50 miles. I don't remember, but they basically said, come on in, we'll retorque them. And I got it finished up at my Ford dealer, and not a word was spoken about coming back for retorquing the wheels. So I'm going to call them this week and say, well, I have a buddy who works there. And I'm going to say, do you guys care about that? And what's the torque spec? Because I'll retorque them. So I'll probably do it myself because, as Dale said to me when we were talking the other day, you probably have a torque wrench. Yes, I do. So we will take care of that. Evils is here. Welcome aboard, Evils. I'm not going to point out that you're late because it doesn't matter. He says temperature is 19 and dew point is 12, but I happen to know that's inside his cell. CJ Stevens says, oh no, I'm late. CJ, dude, we will hold it up for you. You are never late. He says 61 degrees and trying to rain in East Tennessee. By the way, if you look at the map and you look at how wide Tennessee is, east is east. You're learning something new today. Well, I hope so. I hope we all learned something new today. So we got the tires done. And then I got to meet with Warren. So I give Warren, okay, it was a set of Stones. I don't want to make it weird. Warren bought a set of Stones, handed it off to him along with some stickers. So he sends me this picture, which was just absolutely glorious. And now let's see if I could show you this. Here's a picture of Warren's wall electrical cabinet. What is this, Warren? So I'm looking at, he put up all the stickers and all the goodies, and there was the best sticker, the best implementation of the P1 sticker I have ever seen in my life, because it's the P1 sticker upside down right next to the P2 sticker, which is right side up, which is all. Does that not tell the whole story? I think that tells the whole story. Anyway, thank you, Warren, for sharing that with us. That was absolutely hysterical. I loved it. Oh, that was on the door? That's on the shop door? Okay, excellent. So Warren just finished, not finished, you never finish, but is building a shop, and it's too clean. There's not enough stickers. So, yeah, we'll send more stickers. CJ Stevens says P1 is usually in distress. Thus, the inverted sticker. Absolutely. So, well, thank you, Warren. That was awesome. Speaking of distress, the low flow air drying system is working great. So I believe I reported last week that everything was working. It was cycling. It was measuring the sensors in all the AMSs. It was making a decision. The decision tree was programmed into Home Assistant, and it was all working great. So, of course, leaving well enough alone is not in my vocabulary. So I went ahead and was looking at the numbers, and we were drying the system using roughly 7% relative humidity air. So that was out of the Kaiser compressor. And yes, I'm wearing the hat today. We're representing. And out of the refrigerated dryer that is part of the Kaiser system. So that was giving us 7.5% air. And it was running pretty significantly. And, we're dealing with rolls of filament in the AMS. And what I had advised you before was that when you look at a roll of filament, you should be picturing a big sponge. And in fact, every piece of plastic you look at, you should be picturing a big sponge. So we had these big sponges, and we're trying to dry these big sponges at whatever moisture content they're at with air that's at a certain relative humidity. To me, everything gets in my head. Everything gets translated to electrical terms. It's like you have a voltage and a resistor, and which is going to a lower voltage. If you want to make a lot of current flow through that resistor, the voltage difference should be bigger, right? Well, the relative humidity should be as low as possible. So I'm saying, gee, I wonder if we can get it lower than 7.5 without going crazy. So I did something which, you could probably have predicted was coming, but I put desiccant back into the system. And in this picture right here, Evils asks, and correctly I might add, aren't you way past crazy already? Yes, I am. So here's the new member of the crew. Is a little a desiccant cartridge on the high pressure side of things, and I acquiesced because it's desiccant, but it's only in one place. I don't have to run around. And we're monitoring it. So if things start drifting upward, we can always go and check the desiccant. So if you're joining us on video, there's the whole system. If you're on audio, I will describe it for you. We're going from high pressure. This is on the right-hand side. High pressure from our system, which is running at about 100 to 120 PSI. It's going into a solenoid valve. And that's what Home Assistant is using to turn the system on or off. Then at high pressure, we're going into the desiccant cartridge. And I talked to my buddy Doug, and we came to the conclusion that it should be on the high pressure side for maximum efficiency. Then we have the low pressure regulator that brings it down to 10 PSI. And then we have our 10 PSI low pressure manifold. And on the far left, there's our pressure gauge for the low pressure side, and you can see it's indicating. And then we have our orifices and then our tubing, and off you go. So that is the current setup. This dropped the relative humidity reading coming out of our low pressure manifold to 3.1%. That was pretty nice. So what I'm seeing now is a much lower duty cycle of the system in stasis when everything is just sitting there. And that makes me happy. So that means we're using less air and the system is turning on less frequently. So that was the latest update, and I'm very pleased with it. And and there it sits. So between fixing the programming last week, which was actually a little screwed up, and adding this new desiccant cartridge, I would call the system as stable as it can be. And yes, Dale, there are 2 ports identified for the next H2D whenever we're ready for that. Dale says, no, he hasn't put in a self-regenerating desiccant dryer yet. So interesting. I think we did a little research on this. Did we talk about it last week? Did we talk about the truck thing last week? I'm not sure we did. Dale said to me that there is a oh yeah, I'll find that picture for you. Paul is requesting a picture of how the airflow gets into the AMSs, and yes, I will find that for you. I do have a good picture of it. Dale told me that there is a air drying system in every truck that has air brakes, and that air drying system is self-regenerating, which is pretty cool. So there are these off-the-shelf self-regenerating air drying systems for intermittent use that is present in every truck, which I think is pretty cool. Let's see. I'm trying to scan for the picture you're asking for here, and we will find it. Let's see. I'll get it. I'll find it for you. Evils asks, on the high pressure side, because the water vapor pressure there is higher? Yes. So the argument that was made for it is a matter of partial pressure, that the partial pressure is going to be higher on the high pressure side, and that's why we do it there. And here you go, Paul. This is a picture for you. That is a right angle swivel type air input. That's 1/4 inch tubing, called a push-on fitting, going to an NPT thread. We have a nylon washer on the outside of the AMS, and then on the inside of the AMS, we have a McMaster Carr available nut designed to go on an NPT thread. And yes, an NPT thread is tapered, but they still make these nuts for it, which is very interesting. And it comes out lovely. Also, you should drill the hole with a step bit, a uni bit. And we used the long, thin uni bit, and it makes a beautiful hole. And that whole installation of this part of the system takes 3 minutes. Does that do it for you? Is that what you needed there, Paul? And if I don't know if I put the McMaster Carr part numbers up on the Discord server for everything, but I can do that for you. The only thing that didn't come directly from McMaster Carr was that right angle widget, but I think they have one. We just have to find it. I happen to have some from a previous project, so I used those. So that's the update on the low flow air drying system. It is really nice, and it's working great. I go downstairs, hit the button to print something, and walk away, and never think about if the filament's dry, because it's dry. And as an example, right now downstairs in the oven are 2 rolls of a PLA Pro from Overture, drying for use later tonight, and we will put those in. My son, if I could brag about my son, he is really learning how to take designs, make designs in Fusion, slice them, run the printers, print the stuff, take care of the printers, and I couldn't be prouder. He's doing a great job. So that's the news from Low Flow Land. The desiccant cartridge did come from McMaster Carr. And one of the things I thought about, by the way, is it's only running 10 PSI. So can you make your own desiccant cartridge out of a whole house filter housing. Think about that. The only difference is one of the connections goes down to the bottom of the container. In this particular case, it has a screen around it, right, to keep the beads a little bit away from the output. But other than that, it's just one of those cartridges. In this case, it had a metal outside with a plastic inside. But at 10 psi, you don't have to worry very much about pressures. So if you wanted to make your own, it wouldn't be bad. And again, I acquiesced because it was a single point of desiccating. So not too hard to deal with. Yeah, Wesley says, I need to figure out how to get air into the house. So I didn't mean to be dragged down the low flow path. One of the things we are currently working on is ways of generating little pumps for air specifically for that system. So you might have a machine shop 200 feet away with compressors all over the place, but in the house you might have your 3D printers, and there's still a way to make this system with a little teeny compressor that's just there for the job. And we're working on that, and we'll keep you posted. So that's what's going on there. So the Wi-Fi air system, yeah. Oh, don't say that too loud, because I will have people starting to ask me about a Wi-Fi powered air system. Bluetooth, yeah, it's a small amount of air, so you could do Bluetooth low energy. Absolutely, sure, This is what I deal with all the time. All right, so I brought something for show and tell on the low flow system. I had talked about, but I don't think I showed on video the new gauges I got. So this is a liquid filled gauge. You can see the bubble on top, and the liquid filled gauge. There we go. The liquid filled gauge prevents it from getting a shock when that valve opens, and these work super nicely. So when the solenoid fires, you see the needle on the pressure sensor to go whoop, and it just no bouncing around, no nothing. But that's the actual gauge with the actual stuff in it, and I just wanted to show that off. So while we're on the topic of 3D printing, we might as well jump into something that happened on the H2D. So I was printing balancing stands. So the balancing stands are, as you know, they're pretty popular. I had a bunch of red filament that I wanted to use up, and I used it to put balancing stands into stock. So now we have stock of the green, which is called pine green, and the red called vermilion red, and they're beautiful. I'll see if I can get a picture here. And they are now in stock along with black. Now, we had not previously had the balancing stand available in black, but now we do, and it is really pretty. So this is the red. This is just showing the corner, which is going to be relevant in a second. That's the red that the balancing stands are available in, and it's pretty nice. So I was printing balancing stands and putting things into stock. In fact, here's a picture of the stock room. There's the stock room, and we're in stock with 3 colors. This is the first time that's been true for quite a while. And we only have 1 in stock in black, but we have 7 of each in the red and the green. And if you're interested, you could head over to pfg.gg/ I can't remember. Just go to pfg.gg and go to product information, and you'll find it. But they're working fantastically well, and there is a balancing video in the works. So we will keep you posted on that. But as part of making the balancing stands, I noticed a teeny itty bitty bit of corner lifting on the face of the balancing stand that was in contact with the H2D textured sheet. Now, I'm a bit of a perfectionist, and this bugged me. So it only happened in a couple of cases, and it didn't affect the gorgeousness or the function of the balancing stand, but I saw it, and it bugged me. And one of the things I printed as a final filament user upper was this Weha screwdriver stand, which I really like, and if you want one, let me know. But anyway, this guy, you can't see it. It's going to be really hard to show you on video, but there's a teeny bit of corner lifting on this. Now, corner lifting, actually there's a YouTube channel called Slant CNC, and they talk about 3D printing. Good guy, not, no business connection, just have watched a bunch of his videos. And he was just talking about corner lifting in printing. And anytime you have a fairly large structure and it has a corner, you have to pay attention to this. Now, I have dealt with this before, but in this particular case, I was a little surprised because it was the H2D, right? And it was also the PLA tough filament. And this combination, I thought was going to be fine. When I had this problem previously on the X1Cs, I had built, using the skirt on the 3D print, I had built a little wall around it because I was hypothesizing that the airflow was overcooling it. Yes, Proteum, I run the, actually that's one of my things. He asks, do you run the bed leveling every time? And the answer to that is yes, I run the bed leveling every single print without exception. So good guess. So that kind of takes care of that. The airflow, there's a part cooling fan on the left side of the yeah, Proteum says I'm jumping the gun a bit because I know the issue. Yeah. Follow along because this gets interesting. There's an air cooling fan, a part cooling fan on the left side of the chamber in the H2D and in the X1C. So I had built a little castle wall around my parts in the X1C, and it seemed to help the problem and make it go away. But then when I transitioned printing the stands into the H2D, it came back again. So naturally, I thought it was the same situation. So in talking to Unix Carbide, who is has extensive knowledge in 3D printing, especially from the early days, I came up with this little corner protector. So this is a little structure. It's 3 grams of filament. It's not much filament. And it basically goes around the corner of the structure and it protects it from the airflow from the fan. It's just a little corner thing. And then it's triangular in shape. In other words, it tapers off as it goes up in Z height until it disappears. So this thing is about 1.5 inches tall, and it goes around the corner. So what you do is you drag this structure into your print, into your build plate when you're slicing, and you bring it up as tight as you can to the corner, and it will act like a little air shield. So I tried a print with that, and in fact, the little teeny defect that I saw was reduced when I used these guys. Not by a lot. It was still there. So I was talking to the guys on Discord. We were going over all the evidence. And I finally decided that, I don't remember how the topic came up, but basically the question was, how even is the heating in the bed? And I said, I don't know, but I do have the tool to help figure that out. So we went ahead and got out the FLIR infrared imager. In my case, it's a TG297. And I bought that one because it goes up to very high temperatures and I can use it in heat treating. But I went ahead and I very carefully took some shots of the H2D heat bed. And what do you know? It is not super even, okay? And if you're looking at the video, you can see the electrical connections obviously start just north of the center of the plate. They parallel over to the east side of the plate, and then they wrap around the periphery. It's sort of it's a pattern that I'm not sure I would have chosen. If you draw a line, a north-south line, dividing the plate, it's pretty clear that the right-hand side of the plate is going to be warmer than the left-hand side of the plate. And at about 15% from the left edge of the plate is a pretty cool region, okay? Again, I'm giving you the verbal description for the guys that are just listening to the podcast, but if you look at the picture, especially the picture in the thumbnail, you'll see the issue. So Evils asks, what's the temperature difference there? I'm glad you asked. Before I answer that question, let's see. Paul said that he doesn't always use bed leveling, and that was another argument against. I always use it. Protium says it's unfortunately a known issue. Reddit's consensus was to either pre-command a bed temperature and let it soak for a few minutes before triggering the print, or sometimes all the preamble, leveling, flow, calibration, etc., can sometimes be enough to let it fully soak. So this is the first time it's ever shown up for me. So I don't think it's a huge issue, but I asked the question, how much of an issue, how much is it and how much does it matter? So the first thing I did, and this is to answer Evil's question, is took some data. And it's about 10 degrees Frankenstein difference as far as I could measure between the coldest and the warmest. So it's not crazy different, but it's different. In the slide that I'm putting up on the screen right now, there's two arrows, and they point to sort of unfortunately, this is temperature versus time for where my target is pointing in the FLIR unit. And that's how I got my data. And that's how I made the estimate that it's on the order of 10. You could argue that it's more than 10 degrees difference, but that's the difference. Yeah, and Dale says he's not had an issue over 1,000 hours, mostly in PLA, PETG for what it's worth. So it's a pretty, the balancing stand's a pretty large structure. And the question was it getting kind of yoinked when the temperature changed and when it cooled off? So I had, in the next print, because I was not done printing balancing stands, I printed the balancing stand. Oh, I should point out that I was printing 2 up, okay? I had to print 1 up. So I dragged it to the right side of the bed, okay, which is the quote warm side, but you could also argue that it's also the more the smoother side from a temperature standpoint. I dragged it to the right side of the bed and I ran everything exactly the same. I used the same corner protectors that I showed you, okay, for the airflow. Now, 2 things are happening. I'm moving it to the right side of the bed, which is the warmer and more homogeneous side of the bed, but it's also furthest from the fan. the short version is it worked perfectly. There was zero evidence of any issue, and in fact, that's what this picture was about. That picture was the problem corner, and it had absolutely no evidence of any lifting at all. So again, we're talking this was a tiny piece of evidence, but it mattered. So another possibility is just to raise the bed temperature a little bit. Okay. So Evils says that's about 5C. So if I just raise the bed temperature 5C, it may all go away. I don't know. But it was a tiny little difference. I see Robin's in the Discord. Welcome aboard, Robin. And I didn't say hello to everybody in Discord. So in Discord right now we have Tucker, we have Wesley.
Shut up, Wesley.
There we go. We have Josh, Bill, Evils, Robin, DBX, Warren Jones, Paul Morley, Kenneke, Jeff, Protein Machining, and Orjan. Welcome aboard, guys. And if you want to join us in Discord, by the way, you are welcome to. Just head over to pfg.gg/Discord and join us. So that was a story on that. It taught me a couple of things. Again, it wasn't a major issue, but I will be trying something. I like these little corner protectors for airflow. Those worked. And I could change the design to have a rounded corner, which is another thing. It would be easy for me to change that design to have a rounded corner. And I might do that. We'll see what happens. Evil says, have you taken this close a look at your other printers? So I did have the issue on the X1C a little bit. And I thought that my adding a little wall, and I did move it, solved the problem. So it was the same thing. And there's a little bit of a confusion in the it's not a very rigorous experiment to nail it down. But I'm not going to, I can't do, a science project if the problem's fixed, then I can move on. So that's kind of where we're at. Otherwise, the H2D has been spectacular, and I have no other complaints. So that's the story. Definite anisotropic temperature behavior on the bed. I kind of wish I could drop in a heat spreader in the form of a thicker piece of material, but I'm concerned about the nozzle being able to get to the little special strips on the back where it goes for cleaning. And Dale says, and they're on sale right now. Just saying. Thanks, Dale. Dale gets a check from Bamboo. Robin says, I had my first corner PLA Pro lifting issue on a large surface when I decided to try slightly opening the door and the top glass while printing. Now, Robin has this is an X1C. It went away when I closed it all up. Interesting. So that would imply it was a thermal gradient issue. I'm not convinced. By the way, I'm also running my printers. When I run PLAs or PETGs, I am cracking the door open and I am lifting the glass up. So I use a clothespin to prevent the door from closing all the way. And then I also have those risers that I made, somebody else's design that I've been using, and it has a place for the top glass to go. So I do open up now also. That might have been part of how I solved it on the X1C. Now, the H2D has its own vents, and it does open the vents, and Functional Print Friday, another good channel on YouTube, he had a whole episode where he talked about that might be insufficient. Like they might need more venting on the H2D. Good question. We'll visit that another day. But the infrared camera did not lie. There is absolutely some action going there, and I kind of wish it was different. So we'll see. Yeah, I can work around it. It's like having it's like every machine tool we have, right? They all have quirks. And, I talk to Dale a lot during the week when we're both solo in the shop working, and oh yeah, this machine, you can't run over this RPM, or this machine you have to, stand on your left foot and tilt your head a little bit. This is one of those things. It's not a showstopper, but this picture's worth 1,000 words. If I'm thinking about, oh, I want to make sure that I'm in the most uniform part of the bed, I'm going to move to the right. And that's okay. Maybe they'll do something a little different in the next printers. We'll see what happens. Anyhow, that's what was going on in 3D printing land. We've burned through, I think, one full spool, almost probably 1.5 kilograms of the Overture PLA Pro. They call it PLA Professional. Overture PLA Professional. And I have to say, very impressive filament. And it prints, we're using it in black. It prints a matte black, very smooth, excellent performance. Been very happy with it. Just a data point. If anybody has any questions, comments, or anything else on 3D printing, heave it out there, because we're going to change topics here in a second and move on. There is a sale going on for the bamboo stuff, and I guess it goes through, at least through the end of November, if not December 3rd. Public service announcement. If you're interested in that stuff, you could save a little money. I don't think I'm going to be taking advantage of it this time, because I think I have enough printers. Robin says Sunlu PLA Plus 2.0 is working well also. Excellent. Tuck says that the bamboo sale is until December 5th. So we had some failed prints in the last 2 days. It has nothing to do with, printers or filament. It had to do with a design issue. So we had a print we were messing around with, Jared and I, and Jared grabbed a piece of this print and he kind of went to break it, and it would not break. And when he got it to break a little piece to break off the big piece, it was still hanging on there, and he bent the thing. And this was the PLA Professional from Overture, and it behaved very much like the PLA, the Polysonic Pro PLA Pro that I had been printing a lot with. Very tough. So some of these PLA Pros are excellent, and I couldn't be happier with them. Greenwood AG says, I wonder if adding insulation to the bottom of the bed would help. We used to have to do that with the Creality machines to help the bed temperature even out. That's an interesting point, because there is certainly room to put some. And I hadn't thought of that. That might be a worthy thing. Don't know. I'll tell you one thing, though. I do not want the printers to become a science project. I really don't. I just want to use them. So getting me over the hump to do something like that would be kind of hard. I don't want to do that. If Bamboo suddenly announced that they have a H2D version 2, which has an improved bed and it was retrofittable or something like that, I would buy the retrofittable one, the parts, and I might even buy another H2D. But I'd like to see an improvement there. Okay, so the other thing that happened this week is, as you know, because we talked about it before, my 8-inch laps were important to get into play, and they're now in play. And I am pretty happy with what I'm seeing so far. But there was some pretty interesting little tricks that I started doing, and I'm going to put a picture up here. This is the 8-inch laps with their 3D printed holders attached to them. You may recall that those are loose. Okay, they're not tight around the lap, and they have a screw which keeps them oriented at least, but again, not tight. So we have thermal isolation and we have mechanical isolation. The big elephant in the room is what the lap is sitting on. So I went on to Amazon and I found these turntables. There are a bunch of them, but basically turntables that can turn slowly, or turn in increments, or turn in an increment in response to a button. A bunch of little programming tricks for these things. There are a lot of them out there, and they're very popular in restaurants for putting something in a window and then having it rotate. That's kind of the applications. And then I was scrolling through Amazon one day doing something, and I noticed there was one with a picture of a model standing on one of these platforms, and it said it had 150 kilogram capacity. And I'm like, okay, I can't ignore this anymore. So I came up with an idea to use it to position the lower lap. So as you know, you do a bunch of lapping, and then you change the position of the laps with respect to each other, and then you do a bunch more lapping, and etc. Well, that's all well and good when your laps weigh 5 pounds each. When they weigh 17 pounds each, it starts to get a little annoying. And yes, I understand there are machines for this sort of thing, but in this case, I am the machine. So I got one of these turntables and started using it for positioning the lower lap while I was, moving around the upper lap. And I have to tell you, it works phenomenally well. And the total cost on these turntables, I want to say it cost me $40. I mean, it was, I don't remember. I should have looked it up before the podcast, but it was not very expensive. And they come in, white and black and some other colors. I think we have a tool here, and we're very fortunate that it was a popular thing in some other market. But it's working really well. Now, in the picture that I'm putting up right now, I will cover that Casa Frog in a second. You can see that there's some shmoo on the plate. There's 3 micron diamond running right now. The plate on the left, which is labeled 2A, is the conditioning plate, and the plate on the right is the working lap. So this was relatively early in the process. So I am not done yet, and you can see that there's a little dark blush on the working lap. And if you closely examine it, you'll see we're not done yet. We have not finished yet. And it is fascinating to look at the surface finish, and you could recognize grinding artifacts, grinding marks, and you could also recognize when those marks are gone. So you think you pulled a part off of your grinder and it's as flat gets, and then you start lapping and you realize, no, we are not there yet, and progress is being made. So that's where we're at right now, is that the conditioning of the laps is proceeding apace. But I wanted to show you this new trick of these inexpensive turntables. Now, I will also point out that on my lapping table, you'll note those 2 thumb screws in the bottom of the tray. There are thread inserts in the top of my tabletop, and those thumb screws lock down the tray. The tray, in turn, there's a piece of 3M. It's not. I can't remember what they call it. The mushroom top fasteners. They are all plastic. They're identical. The 2 halves are identical, and there are 3 stacks of those on the bottom of the turntable. So the turntable is basically attached to the tray, and then the bottom of the lap also has 3 of them, and those are attached to the turntable. So this is nice and rigid. It withstands the pressures of hand lapping, no problem. And it will go ahead and rotate the bottom lap as I desire. Now, I am working on the protocol, the recipe for how I want this thing to behave. And I don't have a final recipe yet, so I don't have any recommendations. But it is coming along, and it is coming along quite nicely. So I'm very pleased about that. So I'll answer questions as best I can. This is, of course, a work in progress, but I am extremely pleased with how it's going. So Casa says, are we allowed to know the average size of parts running on these laps? In other words, do they cover at least 3 or more tiles at all times during the lapping? So the part is actually going to be a 6-inch part, and that's less of a ratio than I wished, but things are already getting out of control here. Yes, the parts will be greater than 3 tiles across for sure. And the other thing that's happening is, in the hand lapping, and I can't emphasize this enough. In the hand lapping, it's in the name. Your hands are picking up force information while you're lapping, and it tells you things. It tells you what's going on. I could tell you that with the rectilinear grooves on the previous laps, when you got into that weird spot where they lined up, you could feel it. Something went on. I don't think I recognized it back then, and that's not happening. It's a uniform pressure at all angles. It's been working great, which is basically what it was supposed to do. The proof of the pudding is in the tasting, and we haven't tasted it yet. So stay tuned. I can't make any absolute declarations yet, but the aperiodic monotile and its contribution to lapping, I think, is so far so good. And we will have more information as we get this thing into a final configuration. So that's the latest. At least one of you is thinking the following thought. It would go faster if you started with 6-micron diamond. I'm not going to tell you which one of you is thinking that right now, but I know one of you is. And the answer is, I know. This is going to go slower. But to quote my client, we're interested in getting it right, not getting it fast. And this is one of those times where I have so much experience with making successful surfaces with the 3-micron diamond. I do not want to head off into the weeds. The other thing that happens is if I run 6-micron diamond on the laps, I'm going to get embedded diamonds, which are 6 microns. And I don't want that. So for the moment, we're sticking with 3-micron and trying to get to the same level of success that we got on the smaller parts. And later, if we think we can, time saver. So, okay, just for everybody's benefit, Robin is referring to time saver. Time saver grits are the, I'm trying to remember, what's the material? It fell out of my head. Yeah, garnet. Thank you. It's the same as in water jets that are used for cutting. Garnet is thank you, Paul. Garnet is a material which will eventually break down and go away. And that comes if you go to buy it on the market. Its brand name is Time Saver. And it comes in different grits. And the idea being that it does not embed and it doesn't stick around, and eventually it breaks down and goes away. Fun fact: it was developed in World War II for engines that you could just put the stuff in the oil, it would lap itself in, and you didn't have to change the oil. It's just like, just leave it there. So my complaint about, or my concern about the diamonds is that they intentionally are not going away. They're a portion of them will embed in the cast iron and stay there, which is what I want. But of course, I don't want them to be, the big boulders. I want them to be the little pebbles. So that's kind of where I'm at. So this is kind of like, if DBX was making a new table in his wood shop. Robin admonishes us. He says, buy it directly from Time Saver. There are lots of resellers ripping you off. I think it's safe to say that if you buy it from McMaster Car, you're going to be okay. And I think that's where I bought my little Time Saver kit, was from McMaster Car. So yeah, use caution. The worst thing that could happen is you go to buy, Time Saver, garnet, and you get some weird off-brand that is not garnet. That will ruin your whole day. So don't do that. Like if it was aluminum oxide, it's not going to break down and go away. So anyway, one day we'll experiment with some other approaches. Oh, I was going to finish the story. So this is like going into DBX's magnificent woodworking shop where he's finishing a table and he's only using fine sandpaper. That's not the normal thing. The normal thing is you do the coarse, then you do the medium, then you do the fine, then you do the ultra fine, and then you're done. But the sandpaper on the wooden table is not burying itself into the table, and in this case, it is. So it's not going to be buried in the work, but it's definitely buried in the lap, and we have to be a little careful. We don't want to screw things up down the road. And we have an existence proof of magnificent results using, the mono-sized 3-micron diamond, which, by the way, I also buy from McMaster Car, and it's the Hypex. Let's see if we could zoom in on this. We're doing it live, folks. Hi-Pres, there it is. That's the material I'm using. Don't use that part number. That's 1 micron, but that's the bottle that happened to be sitting in the picture. Okay, so that's the story. That's where the 8-inch laps are. And this week, I will be spending a lot of time on the laps and getting them into condition. Once I'm satisfied that the laps are as good as they can be, the work will go on it. And we will do that. The other step that's going to happen here this week is I'll be making a 3D printed fixture for holding the part that I'm doing for my client. So, did I say I was satisfied?
We're not satisfied until you're not satisfied.
Thank you, Dale. We appreciate that. So I will be designing the structure that will hold the customer part for the hand lapping. So I haven't done that yet. That'll be early this week. And then we go. It's all in the preparation. There's so much time spent in the preparation. It's like painting. You prepare, and then it's an hour and you're done. Right? Isn't it always just an hour and you're done? I think I answered your question, Casa, and And Dale said he was satisfied. And I think that's it. If you guys have any questions, throw them into the chat, because I think otherwise we're gonna start wrapping this thing up. And if you're interested in some flat things, head over to PFGstones.com, where you will find the famous, I know this is hard to believe, PFG Stones, but also the balancing stand, the BS8, is available. Video coming. The BS8 is designed for up to 8-inch wheels. And read the info page, because it will talk to you about what you can and can't do. The balancing rings are sold separately. Oh, I made a little change in how I do things on the sales part of the site. Now, if you buy a balancing stand, you will get an automatic discount for buying a balancing ring, which is actually a little bigger than it used to be. And you'll save a little money buying a balancing ring, because it's the logical thing that people do, so they want to buy it. But it will show up as a automatic discount, and that has been put into the text on the product purchase page. Purchase page. Let's see. Did we get answer all the questions? We say thank you to all the peoples. We should be here next week. I don't think there's anything happening that's going to prevent us from showing up. I will have more of a report from Lapland. You see what I did there? I'm just going to check the calendar and make sure I'm not putting my foot in my mouth. Yeah, it looks great. So with that, I look forward to seeing everybody. If you have any questions, you can reach me at pfg.gg/contact. And send me a message. In the meantime, get flat, stay flat, and we look forward to seeing you guys next week. Thanks.